4-inch polyvinyl chloride conduit is appropriate for this application. To minimize voltage drop, 300 kcmil aluminum XHHW-2 conductor should be used. The voltage drop can be calculated using the formula voltage drop equals total length times load current times impedance, all divided by 1000. Consider these assumptions. The load current is 200 amps, based on a 200 amp service. The total length is 575 feet, representing the one-way distance. The impedance is 0.21 ohms per 1000 feet for 300 kcmil aluminum XHHW-2, data obtained from the manufacturer. Now let's calculate the voltage drop. Voltage drop equals 575 feet times 200 amps times 0.21 ohms per 1000 feet divided by 1000, which equals 2.42 volts. The calculated voltage drop of 2.42 volts is acceptable. The National Electrical Code allows for a maximum voltage drop of 5% on branch circuits and 3% on feeders. The voltage drop is only 1.21%, which can be determined by 2.42 volts divided by 200 volts times 100. In conclusion, based on these calculations, 300 kcmil aluminum XHHW-2 conductors in a 4-inch polyvinyl chloride conduit will provide adequate capacity and minimize voltage drop for this underground service. When calculating voltage drop, it's important to use accurate values for the parameters involved. The formula voltage drop equals total length times load current times impedance divided by 1000 is a simplified version. More complex formulas may be needed for more accurate results. Factors such as power factor, conductor temperature, and skin effect can influence impedance and voltage drop. The National Electrical Code provides guidelines for voltage drop in branch circuits and feeders. These guidelines are intended to ensure that electrical equipment operates properly and that voltage drop does not cause safety hazards. The NEC recommends a maximum voltage drop of 5% for branch circuits and 3% for feeders. These are recommendations, not mandatory requirements. Local codes or regulations may have more stringent requirements. When calculating voltage drop, the one-way distance of the conductor run must be used. Using the total length of the circuit, including the return path, will result in an inaccurate calculation. The load current is the amount of current that the circuit is expected to carry. For a service entrance, this is typically the service rating. For a branch circuit, this is the load that is connected to the circuit. The impedance of a conductor depends on its material, size, and temperature. Aluminum conductors have a higher impedance than copper conductors. Larger conductors have a lower impedance than smaller conductors. Higher temperatures increase the impedance of conductors. Manufacturer's data provides impedance values for different conductors at different temperatures. The voltage drop calculation determines whether the voltage drop is within acceptable limits. If the voltage drop exceeds the limits, the conductor size needs to be increased or other measures should be taken to reduce voltage drop. The NEC provides tables that list the allowable ampacities of conductors. These tables are based on the conductor material, size, insulation type, and installation method. The ampacity of a conductor must be greater than or equal to the load current. The XHHW-2 insulation is a thermoset polyethylene insulation with a maximum operating temperature of 90 degrees Celsius in dry and wet locations. It is commonly used for power distribution and feeder circuits. When installing conductors in conduit, it is important to follow the NEC guidelines for conduit fill. The conduit fill is the percentage of the conduit's cross-sectional area that is occupied by the conductors. The NEC limits the conduit fill to prevent overheating of the conductors. The type of conduit used can also affect the ampacity of the conductors. For example, conductors installed in rigid metal conduit have a higher ampacity than conductors installed in polyvinyl chloride conduit. This is because rigid metal conduit provides better heat dissipation. The grounding conductor provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and prevent electrical shock. The size of the grounding conductor must be in accordance with the NEC. The NEC provides tables that list the minimum size of the grounding conductor based on the size of the ungrounded conductors. When installing an underground service, it is important to follow all applicable codes and regulations. This includes obtaining the necessary permits and inspections. It is also important to use qualified electricians to perform the work. Underground services are subject to different environmental conditions than overhead services. This can affect the lifespan and performance of the conductors and other equipment. For example, underground services are more likely to be exposed to moisture and corrosion. The depth of the underground service is determined by the NEC and local codes. The minimum depth is intended to protect the conductors from damage. The type of soil can also affect the depth of the underground service. For example, underground services installed in rocky soil may need to be deeper than those installed in sandy soil. The location of the underground service must be marked to prevent damage during excavation. The markings should be visible and durable. The underground service should also be located away from other utilities such as gas lines and water lines. The type of backfill used for the underground service can affect the performance of the conductors. The backfill should be free of rocks and other debris that could damage the conductors. The backfill should also be compacted to prevent settling. The use of a sand or gravel bed can help to protect the conductors from damage. The installation of a warning tape above the conductors can also help to prevent damage during excavation. The warning tape should be buried a few inches above the conductors. The voltage drop calculation provided is a simplified calculation. More complex calculations may be needed for more accurate results. The impedance of the conductor can vary depending on the frequency of the current. The skin effect causes the current to flow primarily on the surface of the conductor at higher frequencies. This increases the effective impedance of the conductor. The power factor of the load can also affect the voltage drop. The power factor is the ratio of the real power to the apparent power. A lower power factor will result in a higher voltage drop. The temperature of the conductor can also affect the voltage drop. Higher temperatures will increase the resistance of the conductor, which will increase the voltage drop. The NEC provides tables that list the allowable ampacities of conductors at different temperatures. The dirting factors in the NEC should be applied when conductors are installed in close proximity to each other or in high ambient temperatures. These dirting factors reduce the allowable ampacity of the conductors. The use of parallel conductors can reduce the voltage drop and increase the ampacity of the circuit. The parallel conductors must be the same size, material, and length. The parallel conductors must also be installed in the same raceway or cable. The NEC provides guidelines for the installation of parallel conductors. The use of a transformer can reduce the voltage drop. A transformer can be used to step up the voltage at the source and step down the voltage at the load. This reduces the current in the circuit, which reduces the voltage drop. The use of a capacitor can improve the power factor of the load. A capacitor can be used to offset the reactive power of the load. This reduces the current in the circuit, which reduces the voltage drop. The installation of a voltage regulator can maintain a constant voltage at the load. A voltage regulator can compensate for voltage fluctuations caused by changes in the load or the source voltage. The selection of the appropriate conductor size is important for the safe and reliable operation of an electrical system. The voltage drop calculation should be performed to ensure that the voltage drop is within acceptable limit. The NEC provides guidelines and tables to assist in the selection of the appropriate conductor size. When calculating voltage drop, remember to account for all factors that can affect the results. This includes the length of the conductor, the load current, the impedance of the conductor, the power factor of the load, and the temperature of the conductor. Consult with a qualified electrical engineer or electrician for assistance in complex voltage drop calculations. Always follow all applicable codes and regulations when installing electrical equipment. The 300 kcmil aluminum XHHW-2 conductors are a good choice for this application. They have a low impedance and a high ampacity. They are also suitable for use in wet locations. The 4-inch polyvinyl chloride conduit is also a good choice for this application. It is durable and corrosion resistant. It is also easy to install. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years. The NEC is published by the National Fire Protection Association. The NEC is adopted by more states and local jurisdictions. The NEC is intended to protect people and property from electrical hazards. The NEC covers a wide range of electrical topics, including wiring methods, for current protection, grounding, and equipment installation. The NEC is a complex document. It is important to consult with a qualified electrical engineer or electrician for assistance in interpreting the NEC. Always follow all applicable codes and regulations when installing electrical equipment. The information provided is for general guidance only. It is not a substitute for professional advice. Consult with a qualified electrical engineer or electrician for specific recommendations regarding your project. The use of aluminum conductors is common in electrical systems. Aluminum conductors are lighter and less expensive than copper conductors. However, aluminum conductors have a higher resistance than copper conductors. This means that aluminum conductors will have a higher voltage drop than copper conductors of the same size. Aluminum conductors also require special termination methods. Aluminum terminations must be properly installed to prevent corrosion. The use of antioxidant compounds can help to prevent corrosion. The connection should be tight and secure. The aluminum conductor should be protected from physical damage. The conductors should be supported properly. The conductors should be installed in a raceway or cable. The conductors should be protected from moisture. The conductors should be installed in a dry location. The conductors should be protected from sunlight. The conductors should be installed in a shaded location. The conductors should be protected from chemicals. The conductors should be installed in a chemical-resistant raceway or cable. The conductors should be protected from fire. The conductor should be installed in a fire-resistant raceway or cable. The conductors should be protected from rodents. The conductors should be installed in a rodent-proof raceway or cable. The conductors should be protected from insects. The conductor should be installed in an insect-proof raceway or cable. The conductor should be protected from vibration. The conductor should be installed in a vibration-resistant raceway or cable. The conductors should be protected from flexing. The conductor should be installed in a flexible raceway or cable. The conductor should be protected from abrasion. The conductor should be installed in an abrasion-resistant raceway or cable. The conductor should be protected from impact. The conductor should be installed in an impact-resistant raceway or cable. The conductors should be protected from compression. The conductor should be installed in a compression-resistant raceway or cable. The conductors should be protected from tension. The conductor should be installed in a tension-resistant raceway or cable. The conductors should be protected from torsion. The conductors should be installed in a torsion-resistant raceway or cable. The conductors should be protected from shear. The conductors should be installed in a shear-resistant raceway or cable. The conductors should be protected from bending. The conductors should be installed in a bend-resistant raceway or cable. The conductors should be protected from twisting. The conductors should be installed in a twist-resistant raceway or cable. The conductor should be protected from stretching. The conductor should be installed in a stretch-resistant raceway or cable. The conductor should be protected from shrinking. The conductor should be installed in a shrink-resistant raceway or cable. The conductor should be protected from expansion. The conductor should be installed in an expansion-resistant raceway or cable. The conductor should be protected from contraction. The conductor should be installed in a contraction-resistant raceway or cable. The conductors should be protected from weathering. The conductor should be installed in a weather-resistant raceway or cable. The conductor should be protected from ultraviolet radiation. The conductors should be installed in an ultraviolet radiation-resistant raceway or cable. The conductors should be protected from ozone. The conductors should be installed in an ozone-resistant raceway or cable. The conductors should be protected from salt spray. The conductors should be installed in a salt spray resistant raceway or cable. The conductors should be protected from fungus. The conductor should be installed in a fungus resistant raceway or cable. The conductors should be protected from mold. The conductors should be installed in a mold resistant raceway or cable. The conductors should be protected from bacteria. The conductors should be installed in a bacteria resistant raceway or cable. The conductors should be protected from vermin. The conductors should be installed in a vermin-resistant raceway or cable. The conductors should be protected from rodents and insects. The conductors should be installed in a rodent and insect-proof raceway or cable.